video off if you don't want to be recorded. And just a little background on what's going on here. A couple months ago, some of the research specialists, which is kind of the main staff role at CHM for the research side of things, we're talking about the role and professional development and things that we were interested in or wish we had gotten in this role. And one of the things we were talking about is just getting more sort of like beginner level training in software stuff like R or Python that can be like a really useful and marketable skill. And so we figured that because I started here 2.5 years ago with almost no R experience, that it would be handy for me to try and take a stab at teaching some of it since I have that beginner's mind experience. But also because of that, I am not the expert in all things R, but I have taken a handful of beginner R classes. So more and more I'm becoming very familiar with what people talk about in the very first class. But we'll be doing this for another couple sessions. So we'll be building over the course of them. They'll be every 2 weeks on Wednesday at 4 p.m. I made an OSF page that has the slides for today and also a file that you won't actually need, but so you can have it to look at later. And I'll generally put files and stuff on here and a feedback survey at the end. So I will get started. I want it to be as informal as possible, so please don't hesitate to ask questions while I'm talking. You can always interrupt me. If you have like a more tech, like troubleshooting, this thing won't work for me question, then I'd suggest putting it in the chat and Dan or Nate can try and tackle it. And the intention of this is for it to go as slow as the least informed person in the group. So we want, if you're like, oh shoot, I missed what that is, things build up in these sorts of, sorry, I'm forgetting how to start a slideshow. Share. Things build up with coding, and so we want you to stop and hear and ask your question and hear what the concept was. I'm going to hide some of you. All right, and also for people that are new to R, the expectation is that things are going to be frustrating and that there's no way around that. Your packages are going to install in a random place in your computer. You're going to have a period that's making your whole script not work. So it's really about like sticking with it, getting through those moments when it's really frustrating, you don't know what to do, and knowing that every problem that you're encountering, somebody else on the internet has had that problem. And if you Google R and then whatever your problem or question is, you'll be able to find somebody who's had a blog post or a forum question about it. So what is R? It has a lot of amorphous definitions. It's a coding language. It's statistical software, and that was kind of its original purpose. And it really is sort of the program that is able to do some of the most advanced and sophisticated stats computing. And I like to think of it also as at its most simple as just a calculator. if you think of your TI-89 in high school, it is basically an extension of that, except it has a whole computer backing it instead of a rinky-dinky chip in that TI-89. And then the oldest definition I've found is that R is but a canvas, paints, and brushes waiting for an artist to channel life's beauty. And that was from Rumi, the 13th century Sufi programmer. And this, I think, is one of the most important questions for people who have not used R before, is why learn it? Because there's a pretty steep learning curve. And a while back, Jeanette, who a lot of you know, was our biostatistician, used this meme, and I really like it. It is showing programming versus manual data processing. And so manual data processing would be like opening up a file in Excel, changing the names of the columns, maybe taking one column, changing all the yeses and nos into ones and zeros, things like that. It goes at a very linear rate, and there's really not a lot of ways to speed it up when you're just pressing buttons. And a lot of us, because we don't have a lot of time to learn new things, end up just doing it that way and getting bored, which decreases the productivity. But when you use programming to handle this sort of thing, you're going to have this long learning curve. You'll think you're getting it. It will not work. You'll go into a pit of despair. And then you'll have a good script finally that can handle all of your data time and time again, which allows you to process data at an exponential rate. So the big reason also is that you never know what has happened to your data. And so using a programming language like R allows you to always keep your oldest, most raw data file and run your script on it to get you as far as you are in your processing. Whereas when you're doing something like Excel, anybody could open it up, anybody could make a random change to it, and you wouldn't have any record of what was changed. And that can be really dangerous. I don't know how many times I've opened up an Excel sheet that I'm using, and there's like numbers in a column that's supposed to be words, or something very subtle has changed, and it can be really dangerous for our data. And then I think a big reason that a lot of people in psychology have made a big push to using R is that the replication crisis really kind of heightened concerns about programming and how it can benefit, or concerns about the lack of programming and how learning programming can benefit our science. And with that, it allows you to have your script where you've written up everything that you've done to your data, and then you can take your data, put it online with your script, and anybody across the world can replicate your exact analyses, and then they can also try and use your code to replicate new data. So there's a difference between R and RStudio, which is kind of a subtle difference, but I think helpful to know. So R is kind of the base language and I think compiler that actually does all of the work. And then RStudio is a program that people have developed that uses R in a really intuitive way to make it easier to code and analyze data. So it is what's called an IDE, an integrated development environment, meaning that everything that you need to do when you're developing a computer program is right here in front of you on one screen. So you have your code editor where your script is. You have the console, which is what your script gets sent to when you run it, and then also where your output appears. You have your environment here, which shows you all of the objects or variables that are available for you to work with, as well as the packages that are loaded. And then, oh, gotta go back. And then you have this multi-purpose one, which can show you files like normal, like your Finder on your Mac, where you can see what files are in the folder that you're in, and also a help area, which allows you to look up any function and see how it works. And so for this, we'll be using the tidyverse, which is a package of functions for working with tabular data. And if you are new to R, you don't know what that means. So a package is a collection of functions that all work together to make certain tasks easier. And if you don't know what a function is, it's a set of instructions for manipulating data. These are my made up definitions. Somebody else probably has better ones. But the tidyverse then is a collection of a bunch of different tools that all contain the instructions for manipulating data that's in a tabular form. So spreadsheets, where you have columns and rows, like in Excel, and which is the vast majority of the data that we work with in the psych research world, but also a lot of business uses a lot of tabular data. And so we always have to pay homage to Hadley Wickham, who is the creator of the tidyverse, and also wrote a book called R for Data Science, which is available for free online. There's a link here. There's also a link on that OSF page. And I'll be loosely basing some of the content off of the R for Data Science book. It for this, for today, I'm using stuff from chapter 4. So the homework will be to go back and look over chapter 4 to look at the things that I did not cover today. There's also Garrett Grollman, who never gets any homage, but I think had a pretty equal amount of help with the book. And so today I wanted to cover 4 of what I see as some of the key components of coding. And that's operators, variables, functions, and packages. Operators are really kind of one of the most simple things in coding. They exist in all coding languages. And some examples are the arithmetic operators. So just the plus signs, subtraction, multiplication, things that we're already really familiar with, and are the same as what you would use for a calculator. Another important group of operators is the logical operators, which allow you to do a lot of pretty sophisticated control of your programming with very simple components. And so things like the lesser than sign, lesser than or equal to. One important thing to point out is that if you want to say that something is exactly equal to something else, you have to use 2 equal signs, because 1 equal sign is used for something else in R. And with these, you're able to do what's called conditional logic, and something that I'm not actually talking about today, but that allows you to set up your computers or set up your script so that it makes its own decisions based on what it's finding. So you could say, like, if X is less than Y, do blank, that sort of thing. And operators are similar to functions in that they change data, but they only ever do one thing. You don't modify an operator with arguments, which I'll talk about more in a sec. So variables allow you to save and store data. They're also called objects for reasons that I don't really understand, but I think everything in R is technically an object, so that's why there's also another word specifically for variables. And the way that you store data in a variable is by using a operator called the assignment operator. And it's these two characters here. And really, it's intuitive in that it's saying like this is added into the variable. And so you can name a variable whatever you want. It's most helpful to give it a name that actually means something to you. But it's the same sort of thing as a variable in algebra, like x, where it can take on any value and can act as kind of a placeholder. And something that can be helpful when you're first learning is to kind of try and speak out what a line of code is doing in normal English. So for this line, it would be that variable name gets value. And I'll show you more like some actual examples of that later. And this is all probably sounding rather theoretical. So we'll get to actually looking at some examples soon. So functions I touched on a little bit. Generally, they're tools for changing data. So changing the value of a variable to something new. You can fine tune functions by supplying arguments. So you can make it do something a little bit differently to fit your exact situation. Generally, they take this form, so you'll have the function name, and then a bunch of arguments that it can take. Sometimes there will be required arguments for the function to work. Sometimes you won't need any arguments. And a function in R is always just a word and then open and close parentheses. And this is what I mentioned earlier, that the equal sign here is used as more or less as an assignment operator for arguments. So that is why you have to use the double equal sign for showing equivalence. There are debates about whether you can use the equal sign in place of the assignment operator, and it is considered bad form, but they do work interchangeably for giving value to a variable. So an example of a function would be read Excel. So read Excel is a tool that when you use it, it takes a path argument, which is the location of a file, and then it imports it and opens it up for you to work with. It has a bunch of arguments. One handy one is the NA argument, which allows you to say, when you're going through all my data, if you find this exact string of words or of letters, then treat those as an NA. So treat it as missing data. And then I already told you what packages are. So I would love for a volunteer to unmute and give us their understanding of what a package is.
A collection of functions.
Yes, Scott, thank you. Exactly. And the tidyverse in particular is extra special because it's a collection. It's really a collection of packages. So it's a collection of collections of functions. The last thing that I want to cover today is naming conventions. So because you can make up whatever name you want for your variables, it is handy to follow a convention so that your code stays easily readable. This first one is called snake case, and it's all lowercase words, and every word is separated by an underscore, so no spaces, no capitals. The other one that is probably most common is camel case here, where the first letter is lowercase, and then each word from then on is uppercase. So there's no spaces, no underscores, no periods. Some people might also use periods to separate their words, and some people might not use any conventions. We at CHM a while back informally decided that we would try and use snake case for most of our files and scripts that we use. And it's, I think, generally the one that most people are defaulting to these days. And for example, like with periods, a period can mean different things depending on the language. It can act as a wild card, which could essentially mean anything. So when you use snake case, you really avoid having any unintended things happen. And generally, I think it helps in learning coding to have a do first, understand later approach, which I admit I broke today. But I want to take a look at a script just to make some of those concepts more clear. So I have RStudio here. This is a script that I'll show you a little later, but I'm going to get us a fresh script. So you can create a new script file by doing that. You got a blank.
Should we be following along, Andrew?
If it's very easy for you to follow along, then sure, but I won't really be telling you to like do this, do that.
Okay.
Especially since like it's hard if you only have one screen. So here in RStudio, we got our script again, and our console, which our script gets sent to. You have the environment here, and this global environment thing shows you all the packages that you have loaded and accessible. And then you can see the file explorer here. It tells me what the current working directory that I'm in has in it. And then if I go up, you can see the next level higher up. So we'll go back. You can also see where it's at there. You can also see what packages you have installed on your computer by looking there. And then there's this help area, which is probably the most useful addition here, having it built in so you can search to find any function that you're not totally sure how it works. In this case, it has the read Excel function that I pulled up, and you can see that path argument that I mentioned, and then all the other arguments that you could potentially give it. Like this one tells the function which sheet of the file to open. So if you want to just use R as a calculator, like I was talking about before, you can just type it into the script area. And so you do 2 times 4. And then if you press Command return, it sends it to the console. So you can see that that line appeared, and then you get the result. I think, I'm not sure what it is on a PC, probably Alt return maybe. The other option is to just click run up here, and it will run the current line. If you have several lines, you can highlight it all and run it, and it will do all of what's highlighted. But you can see that the results are just getting output, so I can see them here, but they're not getting stored anywhere, so I can't manipulate or work So that's why we assign our data to variables. So if I wanted to have a variable like my number, I'd add the assignment operator here, and I can give it a value of 9. And so when I run this, it gives my number, it creates my number as a variable and gives it the value of 9. So you can look over here in your environment to see what variables you have. The variables are able to be overwritten. So if I wanted to have this here and give it value of 3, then if I run that, it will overwrite it. So now it's 3. You can store the output of a arithmetic operation here. And you could also if you can also perform arithmetic on variables. So R is very handy and will help you with whatever by suggesting names that it knows are in your environment. So if I wanted to do my number times my number 2, which is the name I gave it, you then get -27. So this is kind of R at its simplest form. One thing that I didn't show you would be a function. And I forget what function he uses here. Yeah, seek is the function that he uses as an example. So seek will create a list of numbers from whatever range you give it. So here it creates 1 through 10. And so you know it's a function because it has these parentheses. All of this, it seems really basic, and you might be wondering like, okay, but how can I actually, this doesn't help me with making my work more efficient. So I drummed up just a little example script here of the sorts of things that R can do. And so another thing that I didn't mention is comments. So if you have a pound sign in a line, it makes, at the beginning of the line, it makes the line not run. So if I run this, it just puts it as text there. It doesn't actually do anything. So I'm just going to go quickly line by line through this and show you what it does. And it's really important that you try and make your data as readable and understandable as possible. So adding comments along the lines to explain what it's doing is super helpful if you're trying to share code with anyone. So these first ones, just load in the tidyverse and also a package called read Excel, which allows you to import Excel files. These conflicts are fine. It's just a normal thing that happens when you import a lot of packages at the same time. And so then this line reads in the data frame. In this case, it's an Excel file from a meta-analysis that I've been working on with Simon and one of his grad students. And you can see it's a normal tabular data. In this meta-analysis. We're looking at mindfulness-based interventions and things that predict attrition, so dropout from the study. And so here I'm just renaming some of the variables to make them snake case. Here I'm creating a new column that calculates the attrition. Here I am selecting just a couple of the columns to make it easier to read. You can see now I've got a new variable here, which just contains the columns that I wanted to look at. And then here I graph it so that we can look at the attrition and how it relates to the average age of participants in a study. So each one of these dots is a different study. You can see it's very skewed, and we now know that, so we can clean up our data and transform it in different ways. And so this is just like a short example of what you could do, but there's endless ways that you can visualize data, move files to different places. One example of something that we use for our study that's super handy, that like it would be a huge pain to try and do by hand, is taking all of the files for each participant that we get, so like 100+ files from a task, and combining them all into one file. If you were to try and do that in Excel, it would be a huge waste of time, and you have to keep doing it each time you got new data, but this is just all automatic. So I have references so I don't get sued for all the pictures that I took. Couple things that I wanted to say are that we have this OSF page that I mentioned at the beginning. I'll be adding content to it as we go along. There's a link to the R for Data Science textbook in here, and then some homework for the next class. Basically just to read that R for Data Science chapter if you want to really get to go back over the stuff I talked about and have some practice problems, and then also try and download and open the file that I was just using, which is right here, and this is it. And then I also have this feedback survey for folks to let me know how this went, because we are doing this for the first time, so we always want to improve what we're doing. Here is that OSF page. Here is the feedback form. And I think, yeah, I guess I'll keep recording, but does anybody have any questions that they want covered? And also, if you have like technical stuff, like your R is not working well, you can stay on the call and we can troubleshoot that. But if you don't have questions, then I will dismiss you for today.
Were you intending that we do anything with R before the next class, which is in 2 weeks, question mark?
2 weeks indeed. So 2 weeks from now, yeah, so sorry, I think I didn't say the last thing. So for the homework on the OSF page, try and download, yeah, share it. So try to download this zip file and unzip it, open the R file, and if you just double click on it, it will open R. And then look through it, try and run it, and so you'll know you successfully ran it if you get that same plot that I showed, the scatter plot. And then also try and pick out a couple examples in the script of operators, variables, and functions. And then at the beginning of next class, we'll go we'll take a close look at the script, and people can take a stab at picking out all the different operators, variables, and functions that are in it. The text colors in RStudio. So RStudio is really handy. Pretty much any IDE will have color that will kind of help tip you off as to what a section of your code is or does. So for RStudio, if you have a comment, it becomes green. So you know if your comment's not green, it's not a comment. Library, for whatever reason, is blue as a function. And then you'll get these warnings when it doesn't recognize a variable that you're trying to use. In this case, it's giving me this warning because it doesn't have the attrition data frame loaded up, and so it doesn't know to look for these variables in the attrition data frame. And then I think that's the same for all these. If you get a red X, that means your code is definitely not going to run. So here, yeah, it's saying this won't work. It will go away if you close it. And then down here, the blue is anything that you've run. And then red is either a warning or it's like, this didn't work. So the warnings are usually fine. This here is just saying like, R is saying, you didn't tell me what to do. So these are the defaults that I went with. And here it's saying, giving a heads up that it removed the rows that have NAs. But if I were to try and do something like that won't work with seek, it will give me an error and it will tell me what that error is. So that's really helpful for knowing how to troubleshoot your code, is kind of looking at your errors and trying to work backwards from there. The course is, okay, Dan, I'll answer that. Yeah, so we'll list it in the wiki. This was bound to happen. That's how you know you've gone on for too long. So if there aren't any other questions, I'll stop the recording, and people that need troubleshooting help or just want to ask a question one-on-one with us, you can stick around.
Thanks, Andrew.